Hi, in this video demonstration, we're going to talk about using Spirent TestCenter to test the LISP functionality of a system under test. LISP is the Locator ID Separation Protocol. The system under test supports the map server and map resolver functions in the LISP environment. We're going to use two Spirent TestCenter ports, depicted on the left and the right here, to test those functions. Spirent TestCenter uses devices to emulate either the ingress tunnel router, egress tunnel router, or both. In this example, we're going to use a device on Spirent TestCenter port 1 to represent the ITR and a device on port 2 to represent the ETR. Hence, our traffic will be unidirectional from port 1 to port 2. The system under test is going to emulate the IPv4 internet, and we're going to emulate IPv6 sites behind our Spirent TestCenter ports. Once you define the Spirent TestCenter ETR device, its IPv4 network-facing address, which is referred to as its routing locator in the global internet scheme, and then the IPv6 in-system IDs or EIDs that are going to be supported by that ETR device on Spirent TestCenter. The ETR will register its EID to RLOC associations with the map server. When necessary, the ITR will look up destination EID to RLOC associations with the map resolver. Those are the associations that were already registered with the ETR earlier. Upon receiving traffic from its local IPv6 EIDs, the ITR will encapsulate the IPv6 traffic as IPv4, and that would be a global routable IPv4 internet header using the IPv4 RLOC address of the ITR, and then with a UDP header, a LISP header, and then an IPv6 header, which is the original IPv6 traffic from the IPv6 EIDs. The traffic is encapsulated in a LISP tunnel, and that would be the IPv4 header, which is the routable portion on the global internet, and then the UDP, LISP, and IPv6 encapsulation. And then it's routed normally through the IPv4 internet, because the internet's going to know the location of the IPv4 RLOCs of each the ITR and ETR just based on the internet routing scheme. Once received, the ETR decapsulates and sends the traffic as the original packets to its IPv6 EIDs. Keeping in mind that in this test example, Spirent TestCenter doesn't actually decapsulate the traffic. So if you were to capture the packets on Spirent TestCenter port 2, you would see that they have, the IPv6 and IPv4, as I mentioned in the encapsulation. But we then can use our signature field in the packets to do all of our measurements for throughput, packet loss, latency, etc. So let's switch to the Spirent TestCenter application. So I've opened up the Spirent TestCenter application, and the first thing that appears is the welcome window. I could either just close it and then connect to the chassis and reserve ports, or go into power mode, which is really just manual configuration. From there, I can connect to a chassis and reserve ports. I've already input my two test chassis. I'm going to use the 1082.017. And once I expand it, I'm going to be able to select the appropriate ports. For this example, I'm going to use ports 9 and ports 11 on slot 2 because they're actually connected back to back. So essentially, while I am using Spirent TestCenter to emulate the ITR and ETR functions, we're also going to somewhat use them to simulate the MS and RS functions too. Now, if I select Next, it takes me to the technology selector. And LISP is actually a routing and MPLS protocol in the context of Spirent TestCenter. I'm not going to enable it yet, so you'll see how we can do that later. So at this point, I actually don't have any other technologies enabled in Spirent TestCenter. First thing I like to do once I've connected is go to my ports, and just kind of do a few things that it's going to make things more intuitive for me. Plus, I want to verify the physical layer. First of all, I'm going to rename these ports as ingress and egress. Keeping in mind that Spirent TestCenter can emulate both ingress and egress, but in this example, to make things more straightforward as far as what is actually occurring where, I'm just going to have port 1 emulate the ingress, the ITR, as well, and port 2 emulate the egress ETR. My ports are set to Ethernet copper. I can see my link is up. If I double check here, I see that I'm using auto negotiation. And so if I click on an individual port, I'll be able to see the auto negotiation status, which is actually 1 gigabit full. And if I want to be sure, I'll check the egress port and see that it's 1 gigabit full duplex as well. So now that I'm confident about my physical layer, I'm going to go ahead and create my devices that will emulate the LISP protocols. So I'm going to add a device to each port using the device wizard. Notice how it's convenient to name the ports, so it makes sense to me when I'm looking at them in other places, just what I'm accomplishing with those. Now, you might think in the device wizard I can enable LISP under routing and MPLS, but this actually has not been incorporated into the device wizard, so at this point I'm just creating traffic-only devices. Now, since they're internet-facing or external-facing links are the IPv4 internet, I'm going to create IPv4 devices, which I could also add VLAN headers if it made sense to do that, but in my situation, I'm just using, if you want to call them, access ports. I'm going to use the default MAC address. I know nothing else connected to the system is using that, so I'm going to change my IP address. If it's back-to-back, I mean, they can be whatever I want them to be. I'm going to have port 1 emulate the gateway for port 2, and then vice versa. I'm not going to step per port. I need both of them on the same subnet, and then I'm going to increment on the least significant bit for my 2 devices. So now when we go to preview, we can see that we have our MAC address, but I need to fix device 1, so its gateway is actually pointing to the device on port 2, so I can do that outside of the traffic wizard. So now I have my 2 devices, and actually I'm going to give these names. This is going to be my ITR device on port 1, and then this is going to be my ETR device on port 2. I'm only going to emulate 1 device. Now, things like links and router IDs are not being used for this, even though it seems like topology emulation, because we're going to be emulating IPv6 EIDs in system devices behind our IPv4 devices here. We're not actually creating devices for that. We're just creating routes. And then, so we're not actually using topology emulation or links. And in fact, the LISP protocol doesn't utilize the router ID, so I can just ignore that. The encapsulation for these devices is IPv4. There's their MAC addresses. And then their IP information is good, except I just need to change the gateway on the first port to point to the IPv4 address of the device on port 2. Now, if this was a real-world test and I was emulating the MS/MR functions somewhere else in the network, this is going to be my local gateways to go out. Think of it as a default route, so to speak. But in this case, since they're just back-to-back, then they're just pointing to each other. I could actually apply this, and then I can resolve the gateway MAC addresses. So from the beginning, I can just double-check that, well, we saw our physical layer was good. Now I'm just going to make sure that the IP settings that I have for my devices are good as well. So now that it's done applying, I can go ahead and start the ARP process on all devices, and I can see that they're resolved. So now I know that that's good. Now, I need to enable LISP in the technology selector, since I couldn't do that in the device wizard at the time. So notice under routing and MPLS, I can enable LISP. And now I have the LISP tab available. And I can set both devices to active. And then, now again, the emulated link is IPv4. We're simulating as though we're connected to the IPv4 internet. So we're going to use that as a locator address family. In fact, I can't change it to IPv6 just because I created IPv4 devices. And that's fine. And let me just scroll over a little bit here. So we can kind of get a glimpse of the device role. Now, by default, we can emulate both sides. And since we set it to IPv4 address family, notice we have the map server, map resolver, IPv4 addresses available, but not the IPv6. In fact, if we change these to just ITR for my ITR device, just ETR for my ETR device, notice the ITR uses the map resolver, the ETR function uses the map server. And again, they're pointing to each other. In the real world testing, you would be using another IP address for your map resolver and map servers, and then we would use our default gateways to get out to connect to those. So, and then there's other settings that we could use. I'll just use the defaults. The ETR device will actually be using this authentication key, so I'd have to make sure that that matched something which was in my system, as well as the ETR device has a map register timer, so it's going to re-register all the IPv6 LISP sites, in this case every 60 seconds by default. Now at this point I don't have any sites. I'm not going to be simulating any IPv4 LISP sites. I'm going to be simulating IPv6, so I'm going to go ahead and select both devices. And then I'm going to go into Edit LISP Site Configurations. And because I had selected both devices before coming in, they're both selected here. And I'm actually adding IPv6 sites. So let's go ahead and do that. And I could use whatever values I want here. I'm going to set this, this will be the first site on my first port, which is the ITR site, and it's just going to assign EIDs 2.1.1:1, and then on the second port, which is where my ETR device is, it's going to increment that from 2.1.1 to 2.1.1.2. I could actually create a lot of LISP sites, so call it a LISP site block. If I want, in this example, I'm just going to do one, but if I had multiple, when I either go to register or I go to resolve, it's going to send the equivalent number of LISP messages based on the number of LISP sites that you've defined. Okay, actually there's also the manage LISP site. Now, when I created the LISP sites, it automatically created these two IPv6 network blocks, which we'll see in the LISP site EID prefix manager. And there's a few extra settings in here that you won't see in your LISP site configuration. So this site is calling in this network block, and it displays what the IPv6 information is. But you have a few more settings that you can set over here in the prefix manager. Your time to live, your negative mapping action. You could even set your priority and weights, which then you can see here under the site configuration. So I've added an IPv6 EID 2.1.1:1 to my ITR device and 2.1.1.2:1 to my ETR device. So when I start my devices, my ETR device will send a register message up to the MS, the map server, registering his IPv4 address as well as the routing locator, the RLLC, and then this IPv6 prefix as the associated EID for that. The ITR, once we create a stream block, which is our traffic that we're going to send to that, will use that information and then resolve that combination of EID to routing locator that was registered by port 2, and resolve the tunnel information, the associated routing locator, and IPv6 EID. So now we have our two IPv6 LISP sites defined. So the next thing we want to do is we want to generate some traffic. So traffic in Spirent TestCenter is referred to as stream blocks. So I'm going to add what we call a bound stream block. And especially since we're doing the dynamic tunnel binding, that's the bound aspect. So when the ITR resolves that EID to routing locator mapping, it could use that to build the appropriate tunnel. So under the endpoints, I'm going to select the encapsulation as IPv6. And then I'm going to select as the source my ingress site and the IPv6 site 2111:1 that I defined. And then my destination is going to be the egress site. It's got to be unidirectional because I'm only emulating ITR on port 1 and ETR on port 2. I could emulate both functions and then create a bidirectional traffic between them. But again, I just wanted you to see where things are coming from. And when we look at the statistics and the result, how things are working there. And it's more intuitive if I only emulate one function on each side. So it's going to be unidirectional. So next is my tunnel binding now. One thing I'll mention, yes, this is a tunnel, but there is no label. It's a LISP tunnel, which means it's encapsulating IPv6 traffic in an IPv4 packet. So it's really not a label, but it's just reusing some of the terminology that the MPLS functionality used for this tunnel binding screen. And so really what we're associating a tunnel with is our ingress tunnel router. And so when it resolves this destination LISP site to the appropriate routing locator for the ETR, it knows how to encapsulate it appropriately. So it filled that in automatically, so you don't have to worry. It knows enough to how to do that. Now for the traffic, I can set whatever I want for the frame size. Keeping in mind though that you're going to have an Ethernet header, maybe a VLAN tag, an IPv4 header in this example, since I'm encapsulating IPv6 and IPv4. That actually uses a UDP header, which is another 8 bytes, and then it uses the LISP. It's kind of a null header. It's all zeros and it's only 8 bytes because it's the LISP data. LISP control packets have a larger header, of course, and then, of course, the original IPv6 packet. So you need to take that into account as in terms of a minimum size frame, including the Spirent TestCenter signature field, which is another 20 bytes. I can add something. Keep in mind that we're talking about, this is the IPv6 frame. It's eventually going to be encapsulated in IPv4 and so on. So the frame portion will be the encapsulations, and then I can do things such as modify the priority settings in the IPv6 header. For this IPv6 traffic, I can add additional headers if I want, but I'm not going to. And then the load that I'm going to send out, in this example, I'm just going to use the default at 10% load. So when I finish this, I have my stream block. And the stream block name, it doesn't really matter what it is. I only have one stream block, so I might just say stream block 1 here. I'm going to go ahead and apply this. So it's transferring all the information that I've changed in the GUI to the hardware. Notice the status of the stream block because it knows, because it has that tunnel mapping, tunnel information is not resolved yet. And so as we'll see in a moment, when we start our devices, we're just going to start all the processes on both devices, that this will get resolved automatically. I'm going to go ahead and pin up my results here. And in fact, I want you to see 3 different types of results for this example. So I'm going to change the view and the layout of results window 1 to 1 column and 3 rows. And then I'm just going to resize things here so I can see more stuff in one view. I do want to see my port traffic, aggregate traffic counters. I want to see my test traffic or my detailed stream results, where it's also going to use the information from the signature field to give me stuff like drop frame counts and latency. And then there's actually a specific result view for LISP that I want to see as well. And just kind of resize things here a little bit so I can see everything that I need to see. There's actually only one stream block, so, but of course there's 2 ports, and then there's my 2 LISP devices. Okay, so we're ready to start our devices, and we can see even in the results view the device state is idle, and I can right click on a device, and there's a LISP menu where I can start just LISP and some other functions for LISP from there, or I can just start my devices, all devices, and it will start all the protocols on them. In the case of that we're in this example, we're only looking at running the LISP protocol, so that's all it's going to start. So I'll go ahead and start them. And notice first of all, the stream block the status already went green. And if we look down the LISP results, we can see our ETR device transmitted a map register message. Our ITR device sent a map request message, which was actually responded to by ETR device. So it seems as though it's performing the MR function as well. But in the real network, of course, you'd be sending those to a real MS and a real MR. And notice that these register messages are going periodically. It's set to every 60 seconds right now. So it'll just keep, the ETR device will just keep sending that indefinitely until I stop the devices. Let's go ahead and start our traffic now. And at the port level, we can see we're sending from our ingress port to our egress. You kind of look at it diagonally, so to speak. The stream block actually tracks both the transmit and receive port in the same record, so it's just as one row in the result view. And the stream block gives you a lot of statistics, including the latency, because there's a Spirent TestCenter signature field in there, and the advanced sequencing, so it's keeping track of drop frames and such. There's a lot more statistics that I'm not really covering here. So that's the basics of how to test LISP. I'm going to go ahead and just mention one more thing. In terms of now scaling this up, I can do a few things to scale this up. I mean, if I wanted to bump up my number of LISP routers, I can increase my device count. So I got to be careful when I do that, though, that I look at these steps and we're not incrementing and duplicating MAC addresses or IP addresses and so on. So be careful with that. Another way to do the scale is just use our existing single ETR ITRs and then bump up the number of sites that's associated with them, which could be as easy as going into the site manager here and just bumping up the LISP site count. Notice when you do that, the address increment is going to be on the least significant bit. So I mean, going from 1 to 100 to 1,000 to 10,000, and that means you're going to have to, send out the appropriate number of mapping messages, and your mapping system, the MRMS system in the network, is going to have to keep track and respond to all those. So it's really easy to scale this up. And that completes this demonstration of testing LISP with Spirent TestCenter.